Hello, I'm Dr. A.D. Kemp, the Hammond Doc. In this video, I want to talk about insulation. Now, insulation is essentially the resistance of current leakage. When you're dealing with conductors, electrical wire, what your desire is for the current to remain in that conductor so that it can flow to the appliance, to the object, the instrument that you're working with, that you want to operate. But if there is leakage of current, loss of current from that conductor, then several things can happen. Because you're talking about voltage here, electricity, current passing through this conductor. Several things can happen. One is that, let me show you, if you have an AC cord here, and of course this material that wraps around, this is the conductor, and the material that wraps around it is the insulation. Now, without this insulation, there is leakage of current coming from here. And several things can happen with this naked wire. One is that if there is a source passing voltage through this wire, and a person touches it, you touch it, then you can get shocked. And certainly if there's enough voltage running through, like 117 volts coming out of in your house current through your wall outlet, 117 volts of electricity, it'll kill you. You can die. By touching, you can become electrocuted. It can be fatal, in other words, touching that. Another thing that could happen is that you of course could lose efficiency, because if this current is supposed to be going to a particular area in an instrument and it's not reaching it at the full capacity, then you have less efficient operation of that instrument. Third, it could cause a fire. I mean, you have leakage of current touching wood, like in a Hammond organ, and on the inside of a Hammond organ. This wire is hot in electricity terms, and if it touches that, it can cause a fire in that organ and can literally burn up the building, the home, your home, or a church. You can also, of course, burn out the instrument because of no resistance, infinite current that's running through here, and as long as it's plugged up, it's got infinite current, no resistance, and burn up whatever this is going to. And if it's inside of an organ, you can just burn up the inside of the organ. Well, you don't want any of those things to happen. So it's important to have insulation, good insulation over the wire, over the entire length of the conductor, with no breaks in the insulation, because you don't want any loss or leakage of current along this line. So that's why it is important, as a Hammond organ technician, that this be evaluated, this AC line be evaluated in a Hammond organ. Now, when I go to work on a Hammond organ, this is the first thing that I will check. And if I find that there is damage to the insulation anywhere on this AC line, then I will refuse to work on that organ until I'm allowed to replace the AC line in that Hammond organ. Now, once I replace it, then I can go on and do the other things that I need to do in terms of repair of the organ or working on the organ. But I will not work on a Hammond organ that has an AC line that has bad insulation. Okay? Now, this is brand new. This is good insulation here on this cable, on this cord. Now, I have a machine sitting here on my desk that I'm going to show you how I use it in situations where I want to test installation, because there you can test for this the insulation of one of these lines. And so I'll come back in another video and show you how I do insulation tests using this instrument that I have. Alright, so until that video, this is Dr. Kemp, the Hammond Doc, saying to you, peace out.